If you're struggling to remember the electromagnetic spectrum, there's some good songs out there. This is my one, to the tune of Video Killed the Radio Star. Oh, oh. Oh, oh. Radio, micro, infrared waves, visible, ultraviolet, X-rays, come on! And that's the song. Anyway, now you remember it, the electromagnetic spectrum is just a long, continuous spectrum of transverse waves. Remember from my last video, those are the ones with the perpendicular oscillations looking like that. Every single electromagnetic wave travels at the exact same speed in a vacuum. That speed is 3 times 10 to the power of 8 meters per second, the speed of light. The spectrum varies in both wavelength and frequency. Here's the spectrum. On this side, the radio side, you have a long wavelength and a low frequency. But on this side, the gamma side, there's a short wavelength and a high frequency. If a wave has high frequency, it's also got high energy. So visible light, what you're looking at right now coming out of your phone, is just a specific little range of those wavelengths and frequencies that your eye is able to detect. Visible light is still an example of electromagnetic radiation. So as well as understanding the order and the changes in frequency and wavelength, you need to understand applications of every one of these electromagnetic waves. Radio waves, we use those for television and radio. You could say communications. Microwaves, the next one, we use those in microwave ovens. So for cooking, say that in your exam, don't just say for microwaves. They also are emitted by your phone. They're what go to the satellites and come back. So communications once again. Then the next one, infrared, that's again used for cooking, for heat lamps, and also infrared cameras. Then there's visible light. The only use for these that's on the spec is fiber optic cables. You always hear those broadband companies yapping about fiber optic broadband. Well, this is what it is. Imagine having a mirrored inside hollow tube. We fire visible light down that tube, and since visible light travels mad fast, 3 times 10 to the power of 8 meters per second, that gives you incredibly fast transfer of data, therefore very fast internet. Next, we have ultraviolet radiation, which is used for energy efficient labs and for tanning, for sunbeds. When you're getting sunburned, that's your body absorbing the ultraviolet radiation emitted by the sun. And the last two, these over here, X-rays and gamma rays, they're the high energy rays, and we use those for medical imaging and medical treatments. Chemotherapy, for example. And that's your electromagnetic spectrum. I hope that was helpful. Save this so you can watch it before your physics paper too. I wish you the very best of luck. You're going to do very well, you know.